Hello friends, welcome back. In this tutorial we will study about framing. Actually what happens, the two main functions of the data link layer are data link control and media access control. Now what happens in data link control? The data link control deals with the design and procedures for communication between two adjacent nodes, that is node to node communication. Data link control functions include framing, flow and error control, and software implemented protocols that provide smooth and reliable transmission of frames between the nodes. In this tutorial we will study only about framing, right? Now see what happens. Data transmission in the physical layer means moving bits in the form of signals from the source to the destination. So what happens, the data link layer packs bits into frames so that each frame is distinguishable from another, right? Data link layer packs bits into frames, right? Data link layer packs bits into frames, right? So that each frame is distinguishable from another, right? So what happens in framing, in the data link layer, sender address and destination address are added to a frame, right? Now actually what happens, the whole message can be packed in one frame, but normally it is not done. Normally a message is divided into smaller frames, right? And frames can be of fixed size or variable size, right? Frames can be of fixed size or variable size. Now what happens in fixed size framing, there is no need for defining the boundaries of the frames, right? In fixed size framing there is no need for defining the boundaries of the frame, right? But in variable size framing we need a way to define the end of the frame and the beginning of the next, right? In variable size framing we need a way to define the end of the frame and the beginning of the next. Historically, two approaches we used for this purpose are a character oriented approach and bit oriented approach. So first of all we will study about character oriented protocols, right? Now see what happens in character oriented protocols. Now in a character oriented protocol, data to be carried are 8-bit characters from a coding system such as ASCII, right? What happens in a character oriented protocol? In character oriented protocol, the data to be carried are 8-bit characters from a coding system such as ASCII, right? Now what happens in this case? In this case the header and trailer, they are also multiple of 8 bits, right? The header normally carries the source and destination addresses and other control information, and the trailer carries error detection and error correction redundant bits. Now what happens to separate one frame from the next? An 8-bit flag is added at the beginning and at the end of the frame, right? And this flag composed of protocol dependent special character, right? This flag composed of protocol dependent special characters, right? And this flag signals the start or end of the frame, right? This flag composed of protocol dependent special character which signals the start or end of the frame. Now there is a problem. Now there is a problem. What is a problem? What the problem is that the problem is if the pattern which is used for the flag is also a part of the information, then what happens when the receiver encounters this pattern in the middle of the data? It will think that it has reached the end of the frame, right? This is the problem. Now what is the solution of this problem? Actually the solution of this problem is byte stuffing. Now what happens in byte stuffing? In byte stuffing, right? In byte stuffing, a special byte called the escape character, right, which has a predefined bit pattern, is added to the data section of the frame where there is a character with the same pattern as the flag, right? So what happened, as you can see here byte stuffing is done. So here what has happened, here a special byte called the escape character, right, which has a predefined bit pattern, is added to the data section of the frame where there is a character with the same pattern as the flag, right? So whenever the receiver encounters the escape character, it removes it from the data section and considers the next character as data, not as the delimiting flag, right? So what happens, this byte stuffing, right? This byte stuffing allows the presence of the flag in the data section of the frame, right? Now what happens if the text contains one or more escape characters? Then what happens, they must also be marked by another escape characters, right? In other words, if the escape character is part of the text, then an extra escape character is added to show that the second one is the part of the text, right? As here you can see in this figure, right? So what happens in this byte stuffing? Byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text, right? Now we will study about bit oriented protocol. So what happens in bit oriented protocol? In bit oriented protocol, the data section of a frame is a sequence of bits to be interpreted by the upper layer as text, graphics, audio, video, and so on, right? Now what happens, in addition to header and possible trailer, we need a delimiter to separate one frame from the another. So what happens, most of the protocols, right, most of the protocols use a special 8-bit pattern, 0, then 6 ones, and then 0 as the delimiter to define the beginning and the end of the frame, right? So if this flag pattern appears in the data, right, if this flag pattern appears in the data, we need some way to inform the receiver that this is not the end of the frame, right? If this pattern appears in the data, then we need some way to inform the receiver that this is not the end of the frame. So what happens, for that purpose a strategy called bit stuffing is used, right? For that purpose what happens, a strategy called bit stuffing is used. So what happens in bit stuffing? In bit stuffing, an extra 0 is added, right? So what happens where this extra 0 is added? So here in bit stuffing, what happens, if a 0 and 5 consecutive 1 bits, right, if a 0 and 5 consecutive 1 bits are encountered, then an extra 0 is added, right? So in this case what happens, if a flag like pattern like 0 and then 6 ones and then 0 appears in the data, then it will change to 0 and then 5 ones, right, and then this 0 and then 1 0. Here you can see this extra 0 which we have added here, it is written in red, right? This is the bit which we have stuffed here, right? So what happens in bit stuffing? In bit stuffing, if a 0 and 5 consecutive 1 bits are encountered, then an extra 0 is added, as it is added here in this case, right? So what happens, it is not mistaken as a flag by the receiver, right? So what happens, if a flag like pattern this appears in the data, that it will change to this one, and it is not mistaken as a flag by the receiver, right? So what happens, as you can see here you can see that we have done the bit stuffing, right? We have done bit stuffing here in this figure, you can see. So what happens, these extra bits which we have stuffed, they will is eventually removed from the data by the receiver, right? These bits which we have stuffed here, as you can see, they are written in red. So what happens at the receiver, these stuffed bits are eventually removed, right?